Hi guys, we're still on our linear functions, so we're looking at now at more details of it. So let's start. You remember on the first video of linear, we discussed that when you're looking at linear functions, the format is y is equal to m x plus c. Okay, and then you can recall that we discussed that if m is negative, what does that mean? Or to say, if the graph is negative, we said that our graph will be like this. If the function is negative, our graph would be like that. So this is for a negative graph, and basically we can say y1 is equal to minus x. And then if we're looking at the graph is positive, m is positive, so in this case we have y equal to x, or y2 equal to x is positive, so the graph would be like that. Okay, so we need now to look at the effect of c here and how it affects our graph. Okay, let's look at our first example here. So we have y is equal to x plus 1. Remember, some people they like to use f at x is equal to x plus 1. I told you earlier that this is the same thing. Okay, so let's look at our table as we used the table on the previous videos. So we're looking at our table as x and then as y. So this is our table. Shortly we look at our table here. We're saying this is 0, this is 1, this is 2, this is minus 1, this is minus 2. Okay, so if we're looking at this graph here, we want to check what c does on this linear graph. Okay, this is our table, we can put it like that. So what happens if x is minus 2? So if x is minus 2, we have y is equal to minus 2. Wherever we see x, we put minus 2 plus 1, and then this is nothing but equal to minus 1. You can put that on the calculator to see it. So let's say we're also now looking at so this can be written as that, or it can be written like f at minus 2 is equal to minus 2 plus 1 is equal to minus 1. It's the same thing. Let's look at x is equal to minus 1. So x is equal to minus 1, it's f at minus 1. F at minus 1 is equal to wherever we see x, we put 1 is equal to minus 1 plus 1. This gives us 0. So you see, if x is equal to minus 2, we're getting minus 1. If x is equal to minus 1, we're getting 0. So if x at f at x0, we're getting 0 plus 1. This is 1. Okay, so when x is equal to 1, we're getting 1 plus 1, of which is 2. When f is equal to 2, so what we're getting here, we have 2 plus 1, this is 3. You can see, so at x is equal to 0, when x is equal to 0, our y is 1. When x is equal to 2, when x is equal to 1, our y is 2, and when x is equal to 2, our y is 3. Okay, hence we can easily now sketch our graph here. Let's look at sketching it now. That was bad then. Let's look at sketching our graph here. So this is our graph. It's continuous. It's continuous. It's continuous. So we have our 1, we have 2, we have 3, we have 1, we have 2, we have 3, and we have minus 1, minus 2, minus 3, and we have minus 1, minus 2, minus 3. Okay, so looking at this, looking at our coordinate is like this. If you're looking from here, we have minus 2 is to minus 1, we have minus 1 is to 0, we have 0 is to 1, we have 1 is to 2, and finally we have 2 is to 3. So that our coordinate, let's look at minus 2 as x, so it's to 1, so minus 2 is to here. Then we're looking at minus 1 is to 0, so this one is here. We're looking at 0, at x is 0, because this is x axis and this is y axis, so x is 0 is to minus x. If x is 0, we got 1. If x is 0, we got 1. So sorry, I made a mistake here. I think it should be minus. This one is supposed to be here. So I made a mistake. Let's start from this. Let's start afresh. Okay. It's actually minus. If you're looking at this first one, it's minus 2. Minus 2 of x is to minus 1. So it should be the other way around. And then we have minus 1 is to 0, which is here. Then we have 0 is to 1. 0 is to 1 is here. This is our 1. And we have 1 is to 2, which is here. And we have it was 1 is to 2, 2 is to 3 is here. Then this is our graph. You can just plot it just like that. So this is our graph of f and x is equal to our x plus 1. Then the domain and range will remain the same. There are no constraints. The graph is still defined at y as an element of real numbers and x to all real numbers. This is our range. This is our domain. Okay, so let's try to look at another example as well. So you see what 1 has done, because you see we added 1 from the original function, which would be here if we were looking at y is equal to x. So when we add 1, this is what is happening. The graph is shifting upward. You can see the difference, right? Let's look at the next example. So that is an effect of C. Let's look at the next example. Suppose we have y is equal to x minus 2. Okay, x minus 2. Let's go straight to our table, x and y. Let's go straight to our table. So okay, we have 0, we have 1, we have 2, we have minus 1, we have minus 2, we have minus 3. So we're looking at that. So let's find out if x is equal to minus 3, what will happen? We'll have f at x is equal to x minus 2. So if x is minus 3, we have equal to minus 3 minus 2 is equal to minus 5. So this becomes minus 5. And then if x is equal to minus 2, it's y equal to minus 2 minus 2 is equal to minus 4. So this will be minus 4. If x is equal to minus 1, we have y equal to minus 1 minus 2. This is minus 3. Okay, so this is minus 3. If x was 0, we'll have y is equal to 0 minus 2. That would be minus 2. If x was to be 1, then we'll have y is equal to 1 minus 2. That would be minus 1. If x was to be 2, we'll have f at 2 is equal to 2 minus 2, of which is 0. So we'll have 0, just like that. Let's look at sketching our graph then. This is our graph. I'm struggling there to make it proper or nice. Okay, let me just be more careful. Okay, so this is our graph. So what is happening here? Yeah, we need to have 1, 2, need to have minus 1, minus 2, minus 3, minus 4, minus 5, and we need to have 1, 2, 3, minus 1, minus 2, minus 3. So minus 3 is to minus 5 should be here. This is minus 3 is to minus 5. They should not here. Minus 2 is to minus 4. This is minus 2 is to minus 4. That should be here, I guess. Then minus 1 is to minus 3. Minus 1 is to minus 3 should be here. 0 is to minus 2. It's here. And then we have 1 is to minus, sorry, we have 0 is to minus 3. 0 is to 2, so we have 1 is to minus 1. 1 is to minus 1, which is here. And 2 is to 0, and this is here. So this is our graph then. Our graph just goes like that. Our straight line graph. Okay, so this is our graph. F at x is equal to x minus 2. So you can notice that when we had the first graph, like the other one on the previous example, that was like this was like that, and this was our graph in the previous example, and this graph was y equal to x plus 1. You see what positive c did. The graph was shifting to this direction up, because you see we're coming from the original graph, of which is this one here. We're coming from this original graph, of which is x is equal of y is equal to x. So you see now, because c is negative here, it's negative 2. If c is negative, the graph is shifting downward. You can see that the graph is shifting downward. So that is what is happening. Still no constraints, the domain remains the same. We can say y is an element of real numbers, and we can still say x is an element of real numbers if you look in terms of domain. So this is our x, this is our y. So now clearly you see what does what this c does. If it's positive, the graph is shifting, and if it's negative, the graph is shifting down. Okay, let's look at another example where we're looking more at our m now. Let's look at this one. Let's look at h is 2, x is equal to 3x minus 3. You see, sometimes you can just use h of x, sometimes you can use g at x, sometimes you can just use y, sometimes you can use f at x. It doesn't matter. It doesn't matter. Okay, so let's look at this example here. Let's quickly look at our table, because you see now our c is negative 3. This is interesting because still we have our m. Now our m is 3. Remember, initial we said that the format is y equal to mx plus c. So you can see our c is negative 3, and in this case our m is 3. You can see previously our m used to be 1 or negative 1. You remember, keep in mind that if m is positive, we expect that the graph will be like that, but if it's negative, we expect that the graph will be like that. So we know exactly, but just by looking at the graph, you can see, just looking at the graph, you can see, okay, my graph will be this one here, or it will be in this direction, because I have positive 3 here, and you're looking at the negative 3 of c. Okay, so my graph should be somewhere around here, because it's moving from the 0 is to 0, it's moving to that side, because this is negative, right? So in mind already you can have a picture of how the graph looks like. Okay, so let's look at it now. We have x, we have y, so we're trying to find it and see what will happen. Let's see what will happen now. So we have 0, we have 1, we have 2, we have 3, we have minus 1, minus 2, minus 3. So let's look at our x. If x is 3, so if x is 3, let's say y is equal to 3 and 2 minus 3, because x is minus 3, sorry, minus sorry about that, minus 3. This is nothing but minus 3, or 3 times minus 3 is minus 9, so this should be minus 12. Okay, let's look at h at minus 2. So this would be minus 12. Yes, we did that. So we have 3 into minus 2 minus 3. This should be 9, because this will give us minus 6. This will be minus 6 minus 3. So it should be minus 9. And what else can I see? Repeating h into minus 1 is nothing but 3 into minus 1 minus 3. So this is minus 6. Okay, you can see already the pattern coming out. So let's look at h at 0. We only have 3 is to 0 minus 3. So this is nothing but minus 3, because this will be 0 minus 3 is minus 3. Okay, let's look at 1 now. Let's look at 1. h at 1 is equal to 3 into 1 minus 3. This is 3 minus 3, which is 0. So this will be 0. And then let's look at another one. H at 2 should be equal to 3. So 2 minus 3. So this is nothing but 6. 6 minus 3, which is 3. And lastly we will have 6. You can check that one out. Okay, let's look at our graph then. This is our graph. We have a lot of, okay, so this is our graph already. Our graph, we need to have more of this one. Okay, icon. You see, because now the graph have a lot, like you see we have negative 12 and we have 6 at the same time. Can we look at 369 as our, we need to look at 369 if you're looking at our y, like this here. We can say this is our 3, 6, and we can say this is our 3. So 3, 6, 9, and we can say this is our negative 3, negative 6, negative 9, negative 3, negative 6, negative 9. Okay, so this is our ratio, just our ratio, because now you see we have minus 12. So if you were about to write minus 12 from 1 to 3 until minus 12, it will be very long. Okay, so this is our x, this is our y. Okay, so let's look at it. So we have minus 3 is to minus 12, minus 3 is here. We have minus 3 is to minus 12, which is here. Okay, so this is look at our sketch. So we have minus 2 is to minus 9. Minus 2, let's say maybe our minus 2 is here and our minus 9 is here, so it should be something like that. We have minus 1, let's say our minus 1 is here, and then minus 1 is to minus 6, so that would be here. Let's say we have 0 is to minus 3, and we have 0 now. We have 1, let's say our 1 is here. We have 1 is to minus 3, we have 1 is to 0, we have 1 is to 0, that should be here, and we have 2, maybe our 2 should be here, 2 is to 3, and we have 3 is to 6, 3 is to 6. You can see our graph looks like this one here. It's look like that. So that is our graph, which is h at x is equal to 3x minus 3. You see what it did? I told you that our graph will be lying from here, and it would be like that because it's negative, and it would be like that because you see, because it's negative and c is pushing it to that direction. But let's look at what because what 3 does, because 3 is no longer 1, and then the 3 is too much like 3. What it does, you see, it squeezes the graph is coming closer like this. So it means if we can get a graph maybe with let's say, for example, if we can look at the graph of y is equal to 9x, let's say, even if we're saying plus 1, so it means that graph will be more closer, like something can be like that, you see, because of that 3. So that is what these numbers does, or what m does. So you're looking at m as negative and as positive, but you're also looking at m as the value. Okay, so let's try to look at another one. Let's say you can say this is our last one there. Let's look at something like yeah, let's look at this one. It's more like interesting. So we have f at x is equal to f at x is equal to minus 3x plus 2. Okay, and quickly to our table. Let's look quickly to our table. This is our table. So we look at 0, we look at 1, 2, can add at least for 3 minus 1 minus 2 minus 3. Let's look at x is equal to 3. So if x is equal to 3, we have minus 3 into minus 3 plus 2. So this would be 11, equal to 11. You can put it in a calculator. We have minus 3 times minus 3 is positive 9, plus 2 is 11. Okay, so we have 11. And we're also looking at now minus 3 when x is equal to minus 2 plus 2. This should be minus 6. So this should be plus 6 plus 2, that should be 8 actually. Let's look at y is equal to minus 3. This should be 8 is to minus 1 plus 2, so this should be 5. Let's look at y when x is 0, minus 3 is to 0 plus 2. This is equal to 2. Hey, sorry, this is 5. This one here is 5. This one is 5. This one is 2. Let's look at x is equal to 1. X is equal to 1. We can have y is equal, x is equal to 1 minus 3 is to 1 plus 2. This is equal to minus 1. So this will be minus 1. And x equal to 2. This will be equal to minus 3 is to 2 plus 2 is equal to so it will be minus 6 plus 2 minus 6. So minus 6 plus 2 is minus 4. You can look at it, maybe it's going to be minus 7. Let's look at x is equal to 3. Minus 3 is to minus 3 or plus 2 is equal to minus 7. This is minus 4 because this will be 9, so it should give you minus 7. It just gives you a pattern. Okay, let's look at sketching it now. Sketching this graph here. We're looking at sketching it. What we need more? Y. We need more Y. This is our X. This is our Y. We can still use the ratio of 3, 6, 9, 3, 6, 9, 12. Minus 3, minus 6, minus 9, minus 3, minus 6, minus 9. You can use any ratio. You can use 2, 4, 6, 8, 10, 12. You can use 4, 8, 12, 16. Any ratio can work. Okay, so let's look at minus 3. Minus 3. Our X is minus 3 and our Y is 11. Minus 3 is here and 11 can be here. So we'll be looking at something like that. Minus 2 or minus 2 can be here, and then our 8 could be here. Minus 1, same as 1 is here. Minus 1 is to 5. 5 can be here. Let's say we're looking at 0 is to 2. 0 is to 2. Maybe that one should be just here, because this one can be here, then this one can be here. Let's say 0 is to 2. We have 1. We have 1. 1 is 2 minus 1. So let's say maybe that one can be here. 2 is 2 minus 4. That one can be here. And we have 3 is 2 minus 7, which can be here. So you can see that our graph should be like something like that. Can be something just like that. Okay, so that can be our graph. And we have f at x is equal to minus 3x plus 2. You see, our C is positive. Our C is positive, pushing our graph this way, pushing our graph that way, that direction up positively. But then our from the original graph of which would be like this one. And then if you're looking at now our minus 3, because you think that it's minus, that's why it's taking that direction, because it's negative. Okay, so that's all I had for you guys for the linear functions. I hope you are trying or you are understanding something out of this video. Thank you so much.